Subject is the electromechanical energy conversion. Subject is electrical machines. 2. You have already read the electrical machine first in 4th semester. Electrical machine 2 contains 4 units. First unit is the synchronous machine 1 that contains following topics: synchronous machine, construction feature, armature binding, EMF equation, binding coefficient. Second topic is equivalent circuit and phasor diagram. Third topic is armature reaction. Fourth topic is OC and SC test. Fifth topic is voltage regulation using synchronous impedance method, MMF method, Portier triangle method, voltage and frequency control of alternator, parallel operation of synchronous generator, operation on infinite bus. Last topic of this unit is the synchronous power and torque coefficient. Next, unit 2 is the synchronous machine 2. It contains the following topic: 2 reaction theory, transient and subtransient reactance, power flow equation of cylindrical and salient pole machine, synchronous motor, operation, effects of varying field current at different load, V curve, hunting, damping, synchronous condenser. These are the topic of unit 2. Now we come on the unit 3. Unit 3, 3-phase induction machine, construction feature, rotating magnetic field, principle of operation, phasor diagram, equivalent circuit, torque and power equation, torque slip characteristic, no load and block rotor test efficiency. Fourth unit, 3-phase induction machine 2. 3-phase induction machine 2, starting, deep bar and double cage rotors, causing and crawling, speed control with and without EMF injection in rotor circuit. Fifth unit contain the following topic: single phase induction motor, double revolving field theory, equivalent circuit, no load and block rotor test, starting method, repulsion motor, universal motor. These are the complete course of this semester. Now we'll start first, that is the polyphase synchronous machine. Polyphase synchronous machine. Polyphase synchronous machine. This is polyphase means synchronous machine having number of phases. Generally, synchronous machine used having 3-phase machines. I have already explained you in the previous semester that type of magnetic system, there are doubly excited system, and I have already given example of doubly excited system is synchronous machines. It means 3-phase synchronous machine is a doubly excited AC machine because its field winding is energized from DC source and its armature winding is connected to an AC source. Synchronous machine is having 2 types of machines device. That is, first is the motor and second is the generator. In motor takes supply, 3-phase supply from AC source, and field winding is energized by DC source. In synchronous generator, field winding, it takes the energy from DC source for excitation of field winding and connected to AC source to deliver the AC power. So these are first we take synchronous generator or
हेलो
alternator.
सर कुछ बच्चे ज्वाइन नहीं हो पाए सर, मैसेज कर रहे हैं ग्रुप में. हेलो,
Who has not joined?
समरेश प्रताप सिंह सर.
Please join timely now.
सर रिकनेक्टेड सर, लेफ्ट हो गया मीटिंग.
Chalo, all have joined. They have left the meeting. Chalo. Next. Now we'll start synchronous generator alternator. The first is the synchronous generator. A synchronous generator is machine. You know there is a 2 types of machine, synchronous generator and synchronous motor. I have already explained you earlier that synchronous motor, in case of a motor, it takes energy from electrical source and delivers the mechanical powers. In the case of AC generators, it takes mechanical energy from prime mover and giving electrical output power. So first we take the synchronous generator, or that is also known as an alternator. A synchronous generator is a machine for converting mechanical power from a prime mover to AC electrical power to a specific voltage and frequency. At a machine rotates at a constant speed called synchronous speed. AC generators are usually called alternator. Why it is called alternator? Because it is delivering AC power. I have already explained you in previous semester, in fourth semester, that is principle of operation. AC DC generator I have explained in the previous semester. In DC generator as well as AC generator, principle of both are the same, but only the difference between two is DC generators are used for small power generation and AC generators are used for large power generations. That is, you can say up to 5 megawatts or more power can be generated by synchronous generator, because its output is you are getting in DC generators, you are converting AC induced EMF with the help of mechanical rectifier in DC, and output of DC generator are DC, but in the case of EC generator, output is in the form of AC. So AC, okay, we are getting AC output. Due to this reason, it is known as a alternator. Synchronous generators are usually of three types because of three-phase type because of the several advantages of three-phase generator: generation, transmission and distribution advantage is obtained in the case of three-phase generator. Principle of operation. Principle of operation: a synchronous generator operate on the principle of electromagnetic induction. When there is a relative motion between the conductor and the flux, EMF get induced in the conductor. If there is no relative motions between conductor and flux, it means conductor is stationary and flux is also stationary. So there will be no voltage will induce in the generator. When there is a relative motion between conductor and flux, then voltage will induce. Consider a relative motion of a single conductor as shown in figure 1. It is placed on the rotor. In this case, this is placed on the rotor and rotor is rotating in anti-clockwise direction. Rotor is rotating in anti-clockwise direction, due to which this is direction is rotating and direction of conductor 1 at position 1. You will see at position 1 what will be happens. At position 1, the flux line, you see that conductor moving towards up direction, conductor is moving towards up direction with velocity v, and because there is a two-pole machines, this is north pole and this will be the south pole. The direction of flux will be from north to south pole as shown in this figure, and conductor is moving in this direction. Due to this reason, what will happen? Due to this reason, there will be velocity of conductor is parallel to the velocity of flux. Then what will happen? The conductor and the flux is in parallel. So conductor will not cut any flux, and when there is no cut of flux, voltage induced in the conductor is 0 and at position 1. When it is moving from position 1 to 2, when it is moving from position 1 to 2, what will happen? This is the, when it is moved at this position, the direction of velocity will be one at parallel to the conductor, to the flux, and other is to the perpendicular conductor. So there is some flux will cut by the conductors and voltage will induce in the conductor. As well as we move from 1 to 2, voltage will induced voltage will increasing. At point 2, the flux will be, the velocity will be perpendicular to the direction of to the flux. What will happen at this position? Maximum flux cut by the conductors and voltage induced at this place is maximum. So voltage induced at point 2 will be become maximum. Now from when conductor is moving from point 2 to 3, when it is moving from point 2 to 3, the direction of voltage start, the direction will again voltage will induce in the conductor, but it is decreasing, and up to point 3 it will be decreased. At point 3 again the related velocity will be parallel to the flux, and the voltage induced, flux cut by the conductor will be 0 at this point, and voltage induced will be 0. When it is moved further at 3 to 4, the velocity will be opposite to velocity of point 1 to 2. So the direction of flux will cut by the conductor and voltage will induce in the conductor, but it is increasing in opposite direction at 4. And at point 4, then again velocity will be become 0. Velocity will be, V will be become 0. Velocity will be perpendicular to the flux. Hence, voltage induced at point B will be maximum. Again, it will be start from 4 to 1. Voltage induced will be increasing. In this way, we will get a maximum induced voltage at point 2 and 4. So we'll see in this figure, voltage will induce at A at 0 voltage induced in the conductor. At point 2, voltage will induce at point 2, maximum voltage will induce. Again at point 3, voltage induced will be 0, and at point 4, voltage induced will be maximum, and again it will come at 0. If you draw the voltage induced versus if you draw voltage induced versus time curve, you find a complete sinusoidal wave at this point.
आवाज नहीं आ रही सर।
हेलो हेलो
सर आवाज
Yes,
नहीं
sir.
आ रही।
Hello.
आ रही सर, आवाज आ रही सर।
आवाज आ रही थी, लेकिन इस पर स्क्रीन पर कुछ लिखो मत तुम लोग, सारी स्क्रीन खराब हो जा
सर
रही
कोई नहीं लिख रहा, आप ही के साइड से
है।
कोई लिख नहीं रहा है स्क्रीन पे, आप ही साइड हो रहा है, शेयर आप ही तो कर रहे हैं।
चलो
भाई ये अपने में से ही कोई कर रहा है।
भाई मत बोलो यार।
तो ये सब सर तो लिखेंगे नहीं जो इस पे लिखा आ रहा है।
You see, this is the wave shape. of induced voltage. If you draw the curve between induced EMF versus time, you will find that there is at point 1 you will see here at point 1 the voltage induced, this is EMF axis, and this axis is the time axis. At point 1 the voltage induced will be 0. When it moves from point 1 to 2, voltage induced will be increases. At point 2 it will be become maximum, and again from when conductor moves from 2 to 3, voltage will induced voltage will start to decreasing, and it at point 3 it will become 0, and again when conductor is moving from 3 to point 4, what will happen? The voltage will start to increasing but in opposite directions. At point 4 voltage induced will be maximum. Again from when conductor is moving from 4 to 1 position, the voltage will induced voltage will start to decrease. At point 4 it will become 0. So you will see that is you are getting induced voltage, AC induced voltage, and this complete from point 1 to 4, this wave shape having one cycle, that is 360-degree electrical degree. So in this way, this because synchronous generator is producing alternating induced EMF. Due to this reason, it is known as a alternator. And in the case of DC generator, also the voltage induced is alternating voltage, but it is rectified. Hence the principle of operation of DC generator and DC motors are same. Principle of operation of DC generator as well as synchronous generators are same. But difference between the DC generator and synchronous generator is, that is, in case of DC generator, voltage induced, in the case of DC generator, armature winding laying on the rotor and field winding is kept on the stator. But in the case of synchronous generator, field winding is laid on the stator core slots, and armature, that is field winding is laid on the rotor slots, and armature winding is laid on the stator slot. Why it is happens, as why it is done? What is the frequency of the induced voltage? Since voltage induced is alternating, and the frequency of induced EMF, let P is the number of pole, N is speed of rotor in RPM, and F is the frequency of the induced EMF. Then F is equal to Pn by 120 Hertz. The frequency will be 20 Hertz. If you find out the speed from this equation, so N is equal to 120 by Pf. Means since P is constant and frequency of induced voltage is constant. Hence, the speed obtained from this equation is a constant. Due to this reason, synchronous machines are rotating at a synchronous speed, a particular speed that is known as a synchronous speed. Now we come, what are the advantages of why in the case of DC generator, field winding is kept on the stator and armature winding is laid on the rotor. In the case of synchronous generator, field winding is laid on the rotor and armature winding is laid on the stator. Why this type difference will occur? If you see, that is, synchronous generator is the generating large power, that is 5 megawatt and above. So for large, and this is a large capacity machines, for large capacity machines, more is and voltage induced by this will be higher voltages, that is 11 kV, 15.65 kV, 21 kV. But in the case of DC generator, voltage induced is 220, 230 volts only, because voltage of EMF generated is larger in the case of synchronous generator. Due to this, it requires more insulating material. It is easier to more insulating material if it is kept on field, that is armature winding is kept on the rotor. The more insulating material will be provided on rotor and the weight of the rotor will be increased. And since the voltage is induced in the case of synchronous generator is more, due to this reason, what will happen? It is easier to insulate stationary winding for high voltage, for which alternator are usually designed. So this is second advantage of using armature winding in stator is the stationary three-phase armature can be directly connected to the load with going through large unreliable slip rings and brushes. Since if the armature winding is at the rotor, what will happen? For taking AC voltage, 3 slip rings are required, and current of the synchronous generator flowing in the conductor is more. What will happen? The slip rings will be, the sparking will occur between slip rings and rotor. So this, due to this, to avoid this sparking and taking connection from stationary position is easier. Due to these reasons, we are armature winding in the case of synchronous generator, we are providing at stator. Third is only 2 slip rings are required for DC supply to the field winding on the rotor. In the case of, if you kept the armature winding on rotor, so there are 3-phase AC supply you are taking out from the synchronous generator. So 3 slip rings are required. In this case, when we are keeping field winding at rotor, what will happen? Only 2 slip rings of light weight is required. Next is, due to simple and robust construction of the rotor, higher speed of the rotating of the field is possible because DC voltage is very less, that is 220, hence insulating material are required is very small, so the rotor weight is the light in due to these reasons, and we can obtain a high speed. Stationary armature may be cooled more easily to provide a number of cooling ducts because the periphery of the large synchronous generator are large and a number of ducts are provided. In the case of synchronous generator, and proper cooling take place in the case of large synchronous generator. What are the basic difference between these two? So these are the, due to these reason, armature bindings are always kept on the stator and field winding is kept on the rotor. Next we come, what is the, now we come on the construction of 3-phase motor.
इसमें सर
Time is,
सर मोर ऑप्शन पे जाके एनोटेट डिसेबल कर दीजिए तो सर ये स्क्रीन पे ये जो कर रहे हैं ड्राइंग वो नहीं हो पाएगी सर, कोई कर नहीं पाएगा फिर।
किस पर?
सर मोर ऑप्शन पे डिसेबल एनोटेट पे क्लिक कर दीजिए तो फिर नहीं हो पाएगा ये सभी। और सर स्क्रीन क्लियर भी कर दीजिए सर।
बहुत सही सौरभ, बहुत सही।
सभी लोग अपने को